Key concept 12, target B.
Yeah, YouTube channel is at Math Videos by Mr. A. Make sure you subscribe so that way you know when new videos come out. Hit the notification button as well. I'll be making videos for Key Concept 6 through Key Concept 14 for Integrated Math 1 Core and Honors.
Example 1a. Directions are to solve the following equations. We have x squared minus 36 equals 0. So we're going to go ahead and drop our line down the middle. Okay. No distributive property, no combined like terms, so we're going to add or subtract. We want to get x by itself, and we want the constants to get to the other side, so we're going to undo the minus 36 by adding 36 to both sides. Okay. On my left, negative 36 and positive 36 will eliminate to give me 0. And go ahead and bring down x squared equals 0 plus 36 is going to give us 36. Okay. Now, we're not doing add, subtract, multiply, divide. Those are steps to solving an equation. We're going to introduce a new step. Just like multiplication and division undo each other, just like addition and subtraction undo each other, we need to figure out something that's going to undo exponents. In this case, it's taking the square root, which we already saw before. So we're going to take the square root. Again, we're taking the square root because we know when we take the square root that the index, the lower number, in the upper left corner is a 2, which means we're looking for pairs. And then x squared, so I'll do this to the side actually, just a note. X times x, if you remember the laws of multiplication of exponents, if they have the same base, you keep the same base, but you add the exponents together. So if we take the square root of x squared, we'll be able to have a pair that comes out nicely. It'll be a perfect square, like, for example, square root of 9 would be 3. Square root of 16 would be 4, because 16 is the same thing as 4 raised to the second. So what we have here then is just x equals, and then normally we would have just 6, right? Because you think to yourself, all right, 36 is 6 times 6. There's my pair. I take out a 6. However, you also have to account for this possibility that this could be negative 6 times negative 6. There's my pair, so negative 6 comes out. So we actually have a plus or minus 6. Okay. Now, you could leave it like that as your final answer. If you wanted to split it up just to make it a little bit more obvious, you can say x equals a positive 6 and x equals a negative 6. That would also be okay. Just be aware that they're the same exact thing. Example 2a, directions remain the same. We have x squared minus 9 equals negative 18, so we gotta solve for x. We bring the line down. Then we're gonna go ahead and there's no distributive property. There's no combined like terms, so we're gonna go ahead and add or subtract. We want to get the x by itself, so we want to get rid of the constant, so we're gonna add 9 to both sides. So the negative 9 plus 9 will cancel. We can bring down x squared equals negative 18 plus 9 is still going to give us a negative 9. So now, in order to get rid of the square, we're going to take the square root of both sides. So on my left, we'll be left with just x. On the right, however, this is where it becomes a little bit interesting just because now we have a negative 9. So what I'm going to do is I'm going to take this to the side just to show you something. Square root of negative 9 is the same thing as square root of negative 1 times the square root of 9. Remember, we can multiply radicals together as long as the index is the same, the little number on the upper left, and they're both 2. Now, we know the square root of negative 1 is just I, and the square root of 9 is 3, so we just take a 3 out. So we take a 3 out, we bring down the I, and don't forget it's still plus or minus. Okay. So again, let me just recap that. The I comes from the square root of negative 1. The 3 comes from here's a pair. I take 1 out. And then remember, we need to account for the possibility that this could also be not just positive 3 times positive 3, but negative 3 times negative 3. So we show that by putting the plus or minus in the front. Now this right here is our answer. Again, if we wanted to separate it, we can say x is equal to a positive 3i. And actually, we wouldn't need the positive in that case because we would just automatically know that that's what it is. And x equals a negative 3i. Final answers. You can either write it like that or you could write it like this. Either way would be acceptable and correct. Example 3a. X squared plus 5 equals 0. We're going to go ahead and solve that. So put your line down. And then distributive property, there is none. Combine like terms, again, there is none. Add or subtract. We want to get rid of the 5, so we're going to go ahead and subtract 5 from both sides. Okay. On my left, 5 minus 5 will cancel. We'll be left with x squared. On the right, 0 minus 5 gives us a negative 5. We want to get rid of the exponent too, so we're going to take the square root on both sides. On the left, we'll just be left with x. On the right, again, to the side, just as a note to ourselves, square root of negative 5 is the same thing as square root of negative 1 times square root of 5. Square root of negative 1 is just I. 5 happens to be a prime number, so it can't be broken down any further. Remember, if there's no pairs to come out, it has to stay underneath. However, whatever were to come out would still be a positive or minus. So you're still going to put positive or minus. We'll bring out the I. And the square root of 5 will stay inside as square root of 5 just because, again, it's a prime number and has nothing to come out with. So you could leave your answer like this, which is usually the common way to do it. Sometimes teachers or whatever problem you're working on, they'll have you separate the answers just to make it obvious that there's two answers. So if we were to separate that, you could tell me that x is equal to a positive I square root of 5, the positive not necessary, and x is equal to negative I square root of 5. So those would also be acceptable ways to represent your final answer. Example 4a, x squared plus 8 equals 0. Okay, so again, drop our line down the middle. We're going to add or subtract, so we're going to get rid of the positive 8 by subtracting 8 from both sides. On my left, that'll cancel. We can bring down x squared. On the right, 0 minus 8 will give us a negative 8. Then from there, we're going to want to take the square root of both sides. So that's going to give us x on the left. Keep in mind that line I drew across is not a fraction symbol. It was more like the end of the operation. Square root of negative 8, I'm going to want to take to the side. That one looks like a little bit tricky to work with. We know that's going to be square root of 8 times the square root of negative 1. I put the square root of negative 1 to the right now because I know that's going to be I, and that comes afterwards. 8 is 4 and 2. 4 is 2 and 2. Bring down the other 2. There's my pair. So 1, 2 will come out. Plus or minus. Remember, we always have to account for that. The I will also come out. And then we have a 2 that didn't have a pair, so it's actually going to stay underneath the radical. So this is an example where we don't have a perfect square, where we can't just take everything out, where it's not necessarily a prime number underneath the radical either, so something does come out, but not everything. And we saw this on a previous key concept when we were working with the radicals. So again, there's your two answers if you want to separate them to make it a little bit more obvious to understand. We have x equals 2i square root of 2, and then we have x equals negative 2i square root of 2. Again, that's just if you want to separate them to make it a little bit more obvious what the two solutions are. Example 5a, x squared plus 6x plus 11 equals 0. This equation is a little bit different than the ones we've seen in this target just because this one actually is in standard form. So it's an ax squared plus bx plus c equals 0 format. So maybe we can factor, right? So if you remember how to factor, we want two numbers that when we multiply give us c, but when we add give us b. C is 11, b is 6. The only factors of 11 are 1 and 11, and there's no way that we can add 1 and 11 to get a 6. So this is actually impossible for us to factor out. So then we have to come up with a different way. So if you think back again to the skills that we have, we're going to complete the square for this one. So let's recap what that means. So we're going to have everything with x on one side and constants on the opposite side. So currently we have x squared plus 6x plus 11 equals 0. I'm going to go ahead and drop my line. I want to get rid of the constant, so I'm going to subtract 11 from both sides since it's being added. That'll cancel that out. I'll be left with x squared plus 6x equals negative 11. Now that I have the constant to the other side, what I'm going to go ahead and do is complete the square. So I'm going to take b, which is 6, divided by 2 in parentheses, raise it to the second. 6 divided by 2 gives me 3. 3 squared is going to give me 9, so I'm going to go ahead and add 9 to both sides. We have x squared plus 6x plus 9 is equal to negative 11 plus 9. On my left, remember this will become some quantity raised to the second. X will be the first one. And then this value here, when we took b and divided it by 2, will be what goes here. And that will be equal to negative 11 plus 9, which is going to give us a negative 2. Okay. Now it becomes like the examples from this target, which we have something that's being raised to the second, so we can take the square root of it. Okay. Both sides. Now keep in mind, I'm going to take this to the side just so you can see what's going on here. X plus 3 raised to the second is the same thing as x plus 3 times x plus 3. So if I take the square root of that, there's my pair. One of them will come out, which is what you'll see right now. So we can take out an x plus 3 equals, we have the square root of negative 2. Again, take that to the side. Square root of negative 2 is square root of 2 times the square root of negative 1. We know square root of negative 1 to be I. Square root of 2 is prime, or 2 is prime. So nothing will be able to come out. So we'll just be left with a plus or minus I that comes out and a 2 that stays underneath. Okay, and I'm going to take this one step further because x is not by itself yet. So we need to subtract 3 to get rid of that positive 3. So then 3 minus 3 is 0. We're left with x equals negative 3. Remember, complex numbers, the real part first, followed by the imaginary, plus or minus I square root of 2. Okay, that right there is my answer. And of course, if we wanted to split it up, we could do that. So if we were to split up, one of the answers would be x equals negative 3 plus I root 2. And the other answer would be x equals negative 3 minus I root 2. Example 6a. We have the quantity x plus 2 raised to the second plus 53 equals 17. As complicated as this looks, it's actually a little bit easier than the previous example because we already have something being raised to the second. So it's not in standard form. So we don't have to worry about trying to factor and then not being able to and then completing the square. We can actually solve this a little bit more like we normally would. So dropping our line down the middle, we're going to want to get rid of 53. So we're going to subtract it from both sides. And the reason we're getting rid of it is because eventually what we want to get by itself in this case is not just the x by itself, but whatever was being raised to the second power, which is x plus 2. So on the left, 53 minus 53 will cancel, leaving us the quantity x plus 2 squared equals, and then on the right, we're going to be left with 17 minus 53, which is going to give us negative 36. Okay, and now we can go ahead and take the square root here. So we'll take the square root of both sides. We saw something like this before, so x plus 2 raised to the second is just x plus 2 times x plus 2. There's my pair. I take 1 out. Square root of negative 36. Hopefully by now we understand that that's just going to be plus or minus 6i. We want to get x by itself, so the last thing to do is get rid of that positive 2 that's in the way by subtracting it from both sides. So then we're going to have, let's see here, x equals, because that'll cancel out, the real part first, negative 2 plus or minus 6i as our final answer. And if we wanted to split it up to make it a little bit more obvious, we have x equals negative 2 plus 6i, x equals negative 2 minus 6i. And I'm sure at some point someone will ask, do we need to split it up? No. I would say just do it for good practice, just because at some point some teacher or some situation or some problem you work will expect you to, and you'll want to be able to know how to do that.